Good morning, I'm Mr. Precella, and this morning I want to talk about solving radical equations for my Math 1314 class. And first of all, I want you to recall some properties involving radicals that you would have seen if you took the refresher course Math 373 or from high school algebra. You would have seen this. Now, I'm not concerned with imaginary numbers here, okay? I'm not concerned with imaginary numbers, so we're assuming that for square roots, all the arguments that I write, if I use an x as the thing under the radicand, I'm assuming that it's I'll say non-negative because it could be 0, but here goes. If we had the square root of x and we squared that, we know that would just, yes, it would reduce to x. And if we had a cube root, if we had a cube root of x and you cubed it, that would reduce to x. That exponent undoes the impact of the radical. In future classes, we'll discuss inverses, but for our purposes, they're just undoing the impact. And in general, if you had the nth root of, I'll use an a for anything, raised to the nth power, the nth root of a all raised to the nth power, that gives us just an a. And it doesn't matter how many terms are underneath that radical. If we had something like let's say the square root of x plus 3, and we squared that, as long as everything's underneath the radical, the square root of x plus 3 squared, the square undoes the impact of the radical, leaving us just the radicand, x plus 3. Now, suppose that plus 3 hadn't been underneath that radical. Suppose we had had this. The only thing under the square root is the x. And then we had a plus 3 quantity squared. Well, how do we square a sum? I'll tell you right now, we're not just going to square the radical and square the 3. There's more to it. Think back to when you had in this class, think back to the first homework assignment when we were squaring complex numbers. You have that perfect square formula you can use if you have that committed to memory, or else, okay, there it is. I heard someone say it. Rewrite it twice. The square root of x plus 3 times the square root of x plus 3. You write it twice, and then what do? 4-letter word starting with an F? FOIL it out. Yes, okay, so the square root of x times the square root of x, that's just a square root of x squared. The square root of x squared right there, we've said that that's just x. And then outer, square root of x times 3, that's 3 square roots of x. 3 times the square root of x, that's another 3 square roots of x. And 3 times 3, that's a positive 9. So this reduces to x plus 3 square roots of x plus 3 square roots of x. How many square roots of x do we have? 6 square roots of x plus 9. So let's notice something. Squaring a square root doesn't always eliminate the square root. Here we had something with the square root and we squared it. The result was even worse than what we started off with. Now we have 2 additional terms that are not under the radical. Here we had 1 term. So when solving equations, remember, an equation is not one of those scales. Whatever you do to one side, you have to do to the other side to maintain balance. So we're going to have to square. If you have a square root that you want to get rid of, you'll square both sides. But let's square both sides intelligently. If you're going to eliminate a radical, before you raise it to both sides to a power, you're going to have to isolate a radical term. So before raising both sides of an equation to a power, before raising both sides of an equation to a power, you must first isolate a radical term. I'll say a radical term because you may have more than one radical term. So if you have more than one radical term, get one of those radical terms isolated. Isolate a radical term. And then if it's a square root, you'll square both sides to get rid of it. If it's a cube root, you'll cube both sides. There's a problem though. When you're solving radical equations, think about this. Let's consider the following statement. I think y'all will agree that what I'm writing right here is a true statement. That's a true statement as long as we have those squares on there. Because when you take a negative and you square it, it becomes what? Positive. So that's a true statement with the squares. But before those squares were written there, was that a true statement? Say no. Okay, no, it's not a true statement. The way that even exponents take quantities that are negative and turn them into positive quantities, you're going to have to check your answers. The numbers that you get as possible answers, you're going to have to manually plug it back into the equation and verify that the left side equals the right side. So I'll say, now what about with, before I write this down, suppose we had, instead of squares, suppose we had, does this happen with cubes? Is this a true statement? Is that a true statement? If you raise a quantity to an odd power, do you change signs? No, you don't. That's not even a true statement. If you take a negative quantity and you cube it, it's going to stay negative. If you take a positive quantity and cube it, it's going to stay positive. So we don't have to worry when we're using odd exponents. It's when we have even exponents. If you raise both sides of an equation, to an even power, you will have to check your possible answers. At the end, they may not both check. If you get two, odds favor one will check and one won't check. I'll say you must check your, and I'm going to put this in quotation because it's possible that one or more of those answers aren't answers at all. And remember, I'd printed out an assignment involving rational equations. We've already worked examples of those. Now, I'm going to move on to the radical equations that are in that same homework assignment. Now, I printed out some equations and we were going through solving them. So now I'm moving on to radical equations. Now, I've told you before I'm a big writer, so I need a lot of room when I'm writing. So some people are small writers and they could squeeze in all the work right there and get that problem done, but not me. Here's the equation. Solve the equation x equals the square root of 32 minus 4x equals 0. And I've written it down here already. Let me make sure I didn't miscopy. X minus, okay, that's the right equation. We have a square root. So what power are we going to have to raise both sides to get rid of that square root? A square. So to undo a square root, we'll have to square both sides. Now before we do that, we must first isolate a radical term. Remember what I said. You don't want to just start squaring right the way that's written. I would think I'm going to pick up this x and I'm going to move it over to the left. So I'll have a negative square root of 32 minus 4x equals, pick up that x, move it to the right, that becomes a negative x. If I'd moved the radical to the right, we wouldn't have had those negatives stuck out in front, but it's still going to work out okay because now we're ready to square both sides. First of all, what happens when you square that negative? That's why I said that it's still going to work out okay, because when you square a negative, it becomes positive. Negative squared, that disappears. What are we going to have left here on the left-hand side? The square will undo the radical to give us just a 32 minus 4x. What have we got on the right-hand side? Negative squared. Once again, that's positive. What's this going to reduce to when we square it? Just x squared. So remember, when I'm solving quadratic equations, I like my leading coefficient to be positive, so I'm not going to move that x squared over to the left. I'll leave my x squared on the right. I'll move the 4x over. That'll become a plus 4x and a minus 32. And that'll factor as x plus 8 times x minus 4. A simple trinomial, pretty painless to factor. And let's see what else we have. That's going to give us x plus 8 equals 0, so x equals negative 8. Or x minus 4 equals 0, so x equals 4. But don't stop and punch those answers into my math lab, because remember, what did I say you had to do? We'll have to check our work now. So plug the equation into, or plug the numbers into an equation that contains radicals, okay? Don't decide I'm going to plug it in right here. It's certainly going to check in the equation without radicals. You have to check the one with the radicals before you started squaring. So I'll just go back to the original form. Okay. I have x minus the square root of 32 minus 4x equals 0. Plug in negative 8 minus, I can already tell this isn't going to work. That'll be a 32 minus 4 times negative 8. That'll become a positive 32. 32 plus 32, that's the square root of 64, equals 0. Now be careful, don't say true. Negative 8 minus 8, does that equal 0? No, it does not equal 0. The left side is negative 16. Negative 16 doesn't equal 0. So we discard negative 8. Now we'll plug in 4. So plugging in 4, we have a 4 minus the square root of, that'll be a 32 minus 4 times 4. 4 times 4 is 16. So that's a 4 minus the square root of. 32 minus 16 is a 16. Is this a true statement? That says 4 minus 4. Yes, that does equal 0. So the only acceptable answer is x equals 4. So we come over here, and in my math lab, you would write, right inside the blue box, you would type in the only number that was acceptable was 4. Yes, 4. Any questions there? So isolate a radical term, and then whatever the exponent, whatever the index is for the radical, that's what uses the exponent. If it's an even exponent, if it were a square root or fourth root, you'll have to check your answers at the end. If that had been a cube root, where I'd cube both sides, I wouldn't bother checking my answers. When you're cubing quantities, negative quantities stay negative and positive quantities stay positive. Let's go on to the next one. Okay, this is number 9 on the examples I printed out to do. The square root of 7x plus 74, that's under the radical, minus 8 equals a 32, equals a 3x minus 2. Where did I get 32? I don't know. Let me make sure I didn't miscopy this problem. Square root of 7x plus 7 minus 8 equals, yeah, there's the next one I'm going to do. It's a square root, so I'm going to have to square both sides. Can I square both sides right now the way it's written? No. What do I need to do first? I need to isolate the radical, so I add 8 to both sides. So that says the square root of 7x plus 74 is equal to, that's a 30, not a 32. Why do I keep 32? Saying 32. It's a 3x, add 8, negative 2 plus 8, that gives me a positive 6. And now I've isolated a radical term, so it's a square root. I'll square both sides. Squaring the left side, that's very nice. It just reduces to the radicand, 7x plus 74. But what are we going to have to do with that 3x plus 6 quantity squared? Yes, you're going to have to write it twice and FOIL it out. So write it twice and FOIL it out. First, 9x squared, outer, plus 18x, inner, another plus 18x, last, 36, okay, and it's quadratic, so I'm going to get a 0. I'll get the 0 on the left side. I want that 9x squared to stay positive, so that's a positive 9x squared. 18x plus 18x is 38x, no, pardon me, it's 36x. We're going to subtract the 7x, 36x minus 7x, that gives me a positive 29x. We have a 36 minus a 74, 36 minus 74, that gives me a minus 38 as my constant. And I'm going through the various possibilities trying to factor this. And when I say I'm going through it, I mean I'm going through it in my head very quickly. So let's see. And the reason I'm confident that these are factorable is because, remember, whatever we get as answers, what are we going to have to do? Plug it back in and check? Well, if we're going to plug it in and check, it should be rational numbers. They're not going to give you something that results in irrational numbers that you have to plug in and check. So I'm very confident that this was factorable. 9x squared, I was making the mistake of thinking 3x and 3x. I bet that's what most of y'all were thinking, but I don't think that's working. I'm going to try 9x and a 1x. And 38, there's not many possibilities. Just 1 times 38 or 2 times 19 and okay, I see it. Let's use a positive 38 and a negative 1. Foil that out in your head. Well, 9x times x, we know that's going to give us 9x squared. We know last times last is going to give us a negative 38. So all we really have to check is the outer and the inner. The outer product, 9x times negative 1, that's a negative 9x. What's the inner product? 38 times x, that's a positive 38x. What's 38 minus 9? Isn't that a positive 29x? That's what we needed. Okay, so that's the correct factorization. It checks there. Set each factor equal to 0. 9x plus 38 equals 0, and x minus 1 equals 0. Move the 38 over. And now what? Divide by 9 to give us x equals 38 ninths. Here, move the 1 over to give us x equals 1. And are we finished? No, since we raised both sides to an even power, we're going to have to check our work. So we have two possible answers. X equals negative 38/9 and x equals positive 1. Here's something that you can do when you're checking your work. You have to plug into the equation with the radical, but you don't have to use the original equation. You can use the one once you move that 8 over to the right, and that's actually easier. You'll see what I mean. We had the square root of 7x plus 74 equals, what do we have over here? Adding that 8, that gave us a 3x plus 6. So let's start off plugging in negative 38/9. Plugging in negative 38/9, I can already tell that this isn't going to check. Look at this radical. Look on the left-hand side here. There's no sign there. So what sign do you assume is there? If you don't see a sign, do you assume it's positive or negative? Positive. So that thing there is positive. Plug in negative 38/9 on the right-hand side. So that's a 3 times negative 38/9 plus 6. Let's see, do I have my calculator? Yes. So let's see. Let me see if I can put this somewhere where y'all can see it. No, let's see. That's not very visible, is it? We'll take 3 times negative 38/9 plus 6. That's giving me a negative 6 2/3. So that is a negative 6 2/3. Can a positive equal a negative? No. So I can tell negative 38/9 isn't going to check. I'm not even going to plug it into the left-hand side. Now the right side. We're plugging it into the square root of 7x plus 74 is equal to 3x plus 6. Oh, this one's going to be an easy one to check. Plugging in 1, 7 times 1 is 7, plus 74. That gives me the square root of 81 is equal to 3 times 1 is 3 plus 6. 9 equals 9. Yes, that checks. So x equals 1 is an acceptable answer. And so the only number that we would write here in the only number that we would punch into my math lab right here, a positive 1. Any questions there? Okay. Number 10. Let me find number 10. Oh, it's another radical equation. It's another one with the square root. Solve the equation. The square root of 3x minus x plus 6 equals 0. And I would isolate the radical first. Let me make sure. I have it written here. Let me make sure I did it. Okay, that looks right. So first thing I would do is I'd isolate that radical. I'd move those terms over to the right-hand side. So I just have a square root of 3x is equal to, that'll become a positive x minus 6. And now what? Okay, we're ready to square both sides. Eventually, I think the next example is something other than a square root. So, but here it's still a square root. Square both sides. That gives me a 3x on the left. What have we got on the right? What are we going to have to do to square x minus 6? Write it twice and FOIL it out. And we'll do that in our head. That's just x squared minus 12x plus 36. get the equation set equal to 0. That gives me an x squared. Negative 12x minus 3x, that gives us a minus 15x plus 36. And let's see. Factor x and x, and 36. This is a simple trinomial. That's not too bad. What would you use? The second sign's a plus. That means it's one of the nice cases for signs. You have two of those first signs, and then a 12 times 3. Does that give us back that negative 15x? Yes. So set each factor equal to 0. That'll give us two values of x, either x equals 12 or x equals 3. Do we need to check our work? Yes, because we squared both sides. When you raise both sides to an even power, that's when you have to check your work. So I'm not going to check. I think I'll use the one where the radical was isolated, where we just had that square root of 3x on the left, and on the right we had the x minus 6. You have to plug it into the equation with the radical to check. Plugging in 12. 3 times 12, that's 36. So we have the square root of 36 equals a 12 minus 6. So 6 equals 6. Yeah, that checks. Plugging in 3. We're plugging it into the equation with the radical, and it's easier, in my opinion, to use the one where the radical's already isolated. 3 times 3, that's a 9. So we have the square root of 9 is equal to 3 minus 6. 3 minus 6 is a negative 3. Does that check? No, it doesn't. When a number doesn't check, it usually doesn't check as a result of some negative being squared and becoming positive. So notice it's almost easy to accidentally say, yeah, that's 3, and say that 3 checks as well. All that's wrong is that sign there. And remember, a number that doesn't check, that you got when you were solving it, but it doesn't check, that's called an extraneous solution. So just some terminology. X equals 3 is an extraneous solution. I think I used that term in the last video, but over rational equation. But for number 10, here we are. The only number that checked was 12. So we would write, or not write, you'd type it into my math lab right there. You type, what did I say, 12. And you might want to start making some generalizations. You might think to yourself, okay, if there's two possible answers for square root equations, one will always check and one will never check. One will check and one won't check. That's not always true. But most of the time it's true. If you're solving a quadratic, a square root equation, and you come up with two possible answers, in most cases, one will check and one won't check. So if this were just some sort of bizarre game where we were gambling, and I knew, okay, this one checks, and I didn't have time to check this one, say it was a test, I was running out of time, I checked this one and it checked, I would just assume then that that one there didn't check and go on if I were running out of time. That's not always true, but it's true most of the time. And if you have one positive and one negative, if you have one positive and one negative, like the previous one here, one positive, one negative, odds favor the positive will check, the negative won't check. It's extremely difficult to rig a square root equation where you get two possible answers, neither of which check. That is extremely rare. In most cases, one will check, one won't check. Number 11. Number 11. Let me tear off this page. It's a fifth root. The fifth root of 8x minus 7 equals the fifth root of 9x plus 6. Okay, fifth root of 8x minus 7 equals the fifth root of 9x plus 6. This is really nice because do we have to move terms around? No, we have two radical terms, both of which are isolated. Are we going to square both sides? No, we raise it to the fifth power, whatever that index is. Once I'm through here, am I going to have to check my work? No, because that power is odd. Odd. So, there's no checking. So, raising to the fifth power, that says 8x minus 7 is equal to, what have we got over here? A 9x plus 6. I'll move the 8x to the right. 9x minus 8x gives me 1x equals, subtract 6, negative 7 minus 6, that gives me a negative 13. And certainly the shortest problem that we've done today, right? There's no checking. There's the answer. We go over here to my math lab. And right in there we type, what was it, negative 13? Yeah, negative 13. And number 12. They can't all be that easy, but it's nice to have an easy one every now and then. Okay. It's a cube root, so we're going to have to check our answers. It's a cube root. No, we're not going to have to check our answers. That'll save us some time at the end. The cube root of 6x squared plus 5x minus 5 minus the cube root of 6x equals 0. Cube root of 6x squared plus 5x minus 5 minus. Okay, there it is. Now this one we're going to, instead of squaring, we'll have to cube both sides. Do we start cubing right now? No, what do we have to do first? We have to isolate a radical term. I think it's easiest to pick up that second radical term, move it over to the right. That becomes a positive cube root of 6x. Then we cube both sides. That gives me a 6x squared plus 5x minus 5 is equal to just a 6x. I'd get this equation set equal to 0. That's a 6x squared minus x minus 5 equals 0. And we're going to have to factor, so do y'all see the factorization? Okay, I think I see it. I'm going to resist the 3x and 2x urge because that's not going to give us that minus 1x that we need when we combine it with the 5. I notice 6 and 5 differ by 1. So I'm going to use a 1x and a 1x and a 6x, and I'll use a positive 5 and a negative 1. Does that do it? The outer product is negative 6x. What's the inner product? The inner product is a positive 5x. Yeah, that gives us the negative 1x that we need. Set each factor equal to 0. To give us x equals 1, or x equals negative 5, 6. And notice I'm just boxing in these answers. I don't have to check them because that was an odd exponent that we used. So here I'd write in my answers of, what were they? This is, actually you'd go to my math lab and type in the answers, okay? You'd type in a -5, 6, -5, 6, comma 1. They want you to use a comma to separate the answers. And how about one more? I'm going to skip over the example 13 that I was doing because we're running out of time, and that's an extremely short one. Here's number 14. 4x plus 6 to the 1/3 minus 6x minus 1 to the 1/3 equals 0. How did this even get in here with these radical equations? Let me make sure I didn't miscopy the problem. 4x plus 7 to... Yep, that's a problem. What do I mean by an exponent of 1/3? An exponent of 1/3, yes, an exponent of 1/3 is the same thing as a cube root. So it could have been written like this. If the problem had looked like this, then it probably would have been a little more familiar to you. An exponent of 1/3 is the same thing as a cube root. And let me get rid of there. These pages underneath there have writing, and there. So now what should we do? What should we do? Okay, isolate a radical. I'm going to pick up the second radical and move it over to the right, because then that negative will become, it'll become positive. So we have the cube root of 4x plus 6 equals the cube root of 6x minus 1. And then we'll cube both sides. Am I going to have to check my answers in a moment? No, because once again that exponent is odd. Oh, this one falls out very nicely once you get over the shock of those exponents of 1/3. Just a 4x plus 6 equals, what have we got on the right hand side? A 6x minus 1. And it's linear, we don't have to factor or anything, just combine the x terms. I'll move the 4x over here. 6x minus 4x gives me a 2x equals, move the 1 over to the left, that'll give me a 7. 6 plus 1 is 7, giving me a final answer of x equals 7/2 for my final answer. So here on number 14, my final answer, the answer I write in my box right there, is 7/2. And I think we're about out of time, so hopefully this will help you get your homework done that involves those equations with radicals. And I'll say goodbye now. Bye-bye.